Hello, my name's Tanner Tribble, and my project was over polyolefins. This is just a timeline of it. They were first produced in the 1930s, although important advances are still being made in improving the process and performance of these materials. It began in 1930. In 1954, the invention of stereospecific catalysts by the Italian chemist Giulio Natta and German chemist Carl Ziegler happened. They were awarded the Nobel Prize for Chemistry in 1963 in recognition for their work on the Ziegler-Natta catalyst. In 1957, the discovery of metallocene catalysts to catalyze olefin polymerization with conventional co-catalysts occurred. In 1961, manufacturing of polypropylene began. Polypropylene is used for products like fibers, fabrics, upholstery, and nonwoven fabrics. These are just certain advantages within polyolefins. Polyolefins are any class of synthetic resins prepared by the polymerization of olefins. Olefins are hydrocarbons, which are compounds containing hydrogen and carbon, whose molecules contain a pair of carbon atoms linked together by a double bond. Polyolefins are by far the largest class of synthetic polymers made and used today. These reasons include they have low cost production, they're lightweight, and they have very high chemical resistance. A wide range of mechanical properties are possible through the use of blending and additives to make products from elastomers to thermoplastics to high-strength fibers. This slide has to deal with polypropylene. The density of polypropylene is between 0.910 and 0.928 grams per milliliters. Therefore, it is a commodity plastic with the lowest density. With lower density, molding parts with lower weight and more parts of a certain mass of plastic can be produced. Polypropylene is normally tough and flexible, especially when copolymerized with ethylene. This allows polypropylene to be used as an engineering plastic, so then it can compete well with other materials like ABS, for example. Polypropylene also has very good thermal properties. Commercial polypropylene has a melting point that ranges from about 160 to 166 degrees Celsius. The thermal expansion of polypropylene is very large. Chemical properties of polypropylene are very important when it comes to processing or different applications. Polypropylene at room temperature is resistant to fats and almost all organic solvents, just apart from strong oxidants. This slide has to deal with different applications with polypropylene. Polypropylene is an important plastic and used in many different forms and applications through a range of manufacturing processes. A large proportion of polyethylene is used in fibers, upholstery, and carpets. Many industrial uses involve ropes, woven and non-woven fabrics, and reinforcements. Blow-molded containers such as bottles for foods, shampoos, and other liquids form part of everyday experience. A wide range of injection molded items exist in appliance housings, resistant containers, car components, toys, and furniture. Many plastic items for medical or laboratory use can be made from polypropylene. This is because it can withstand heat from the autoclave within the medical field. And then rugged, translucent, reusable plastic containers. Those are all different applications within polypropylene. And the two pictures below are just certain examples of products that could be made. This slide has to deal with polyethylene. Polyethylene is a low strength, hardness, and rigidity, but has a high ductility and impact strength as well as low friction. It also shows strong creep under persistent force, which can be reduced by addition of short fibers. It has a waxy feel to it when you're handling the material. It has a low melting point for common commercial grades of medium and high density polyethylene. The melting point ranges from about 110 to 140 degrees Celsius. These temperatures, though, can vary strongly with whichever type of polyethylene is being used. Carbon black is usually used as a UV stabilizer. Since polyethylene can become brittle when exposed to sunlight, that's why carbon black is used as an additive. An example of this could be zip ties. If it's a clear zip tie and it's outside, it's going to become more brittle and break way more easy than if it was a black zip tie, since the black zip tie has the carbon black additive in it. These are different applications within polyethylene. It is one of the most widely produced plastics in the world. Tens of millions of tons are produced worldwide each year. Polyethylene is used in applications ranging from films, tubes, plastic parts, laminates, etc., for several markets like packaging, automotive, and electrical fields. Applications for polyethylene are enormous since you can use high density polyethylene and low density polyethylene. Pictured on the right is a cooler and different types of bottles that high density polyethylene is used for. This slide would be my YouTube link, and thank you for joining me.